Everybody, it's Tyler here at the Texas Cup, checking in team number 4206 Robo Vikes coming in from Fort Worth. This is a brand new 2021 robot we're going to be focusing on. Just saw this team play. Really accurate shooter that they have. Can't wait to see more of it, how it details and how it plays. And to help me do that, I have Henry, Graham, and Andrew. It's going to be speaking more about this robot, what goes into it, all here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on FIRST Updates Now for free? Events that stream on FIRST Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on FIRST Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events. So starting out on the intake here, Henry, tell me more about some of the design process of it, what went into it, and any iterations you might have went through while building it.
Well, the design process, it was mainly taken from last year's feeder that we used on our 2020 robot, and we more specifically adapted it to this year's robot, and we made a couple changes that are a lot better, including our single action pistons with springs in them, which help include the loss of air over time. So now we just have rubber bands and springs inside the pistons, so it's a lot easier to keep our air inside the compressors without turning it on. And we also have included new rollers, these new bearings that we made in-house on our 3D printers and designed. These help us funnel the balls more inside the robot without actually having a funnel, and it's a lot easier to get out of caught when the balls catch in between this and the swerve drive. Including with that, this was mainly made out of polycarbonate white, which we have used last year, and this is our main structure for last year. But including that, it's very strong and light, which is why we like it.
So let me ask you on the front here with these bearings, by the way. So very interesting, these bearings are all kind of at different angles. Can you tell me just a little bit more about how this works here?
What happens is when this rolls, it acts almost like a corkscrew touching the ball, funneling it to the inside. And if you roll it the other way, it will have the opposite effect. So that you'll have to get these on the right side. These are different versions of this side. More specifically, that when this spins the right way, these will almost touch the ends and just corkscrew right to the center where we want to feed.
Can we see the intake deploy out, by the way, just so we can take a look at that? So, a couple things to ask on this. So you got these holes up here. Are these for anything with the power cells or anything like that?
Those were created last year for weight saving.
Okay, sure.
And we've
Speed
just been
holes,
gone
right?
by the name of cup holders for the past year.
Well, I wasn't sure if it was something like from a human player load or something like that,
No.
but that totally makes sense. Let's move on to Graham. Is going to be talking about the Spindexer inside your robot. So we'll go into that, talk about what makes it work, some of the thought process behind that as well.
Starting off with the Spindexer, we had to go through many prototypes to get this working. It's combining having mini balls in there, yet maintaining space and inventory on them while also being able to shoot correctly. So first we have the main spinning wheel. That's the indexing part of the Spindexer with our spokes, which we made out of clear polycarb, so our drivers could see if there's any jams or anything like that, which was a major point of our prototyping process. And also these wedges, which we had to get near perfect to make sure that no jams happened while it also kept the ball in place. As it spins around on these gears you can see around the circle, it is moved around by the sim motor with a green rubber wheel around it. That's what gives it its friction to spin. And then it goes over to this kicker wheel right here, which moves downwards and causes it to go into there. We'll actually show you a demo of that right now. Alrighty, so this is almost its neutral position where it slowly works downwards as it spins, and then whenever we want to shoot, it reverses and then shoots it up through the flywheel onto the shooter. Other than that, a lot of work had been going to the math for this wheel. since we did not want it to jam going downwards, while also we didn't want it to stay still. As if it stayed still, that's ensuring a jam. So you had to get a right little Goldilocks zone in there to find the best position to shoot it correctly.
It's interesting to see that because a lot of teams that we talked to that have had the dividers actually end up taking them out because sometimes it becomes more hindrance. But I like that you worked through it and were able to still keep it in the whole time as well too. So that makes a lot of sense there. Take us through as we go into the shooter. You know, as I saw your team compete just a little bit ago, you guys are able to shoot from a pretty far range and quite accurately as well too. So tell me what goes into it. Want to hear more about the flywheel and stuff that goes into this as well.
So at first we started with the rubber flywheels, as most teams have. We saw a lot of degradation on it though, and we had to clean them up a lot. But what really gave us our range was our brass flywheel that was custom manufactured for this, and in tandem with our adjustable shooter as well. Our shooter hood is run on 2 servos in the back, which allows us to have different angles. If Andrew wants to show us right here, you know, going up will make us shoot lower. And originally we were going to adjust this mid-match, but we found our best angle in between that. And in tandem with the flywheel, we got a lot of pressure on those balls to then fly out. That's what gave us a lot of our offensive position inside of the trench right there. Other than that, we have a limelight in the front, which helps us with our targeting, as well as switching to a camera mode, 2 falcons right there for the speed on those flywheels. And a lot of it was just finding the right math to switch in those RPM, find the right RPM in tandem with the hood, and see how far we can get it.
Last thing I want to ask you on here is talking about this 3D print that you have for your hood. What made you choose this material, and how did you get your compression to where you thought it was going to be at the right amount for you?
So yeah, this is just a typical ABS plastic. We were going to go with a stronger, I think, carbon fiber mixed with some other material print. But we found that due to the metal custom CNC'd metal sides, it wouldn't be putting much pressure directly inwards on the print. So we can kind of, you know, balance it right there and then get it shooting out with the maximum pressure on the top without breaking our 3D part. And, you know, it was just a mix of finding the right position and having the right bolts in the right place for this.
Well, let's wrap up on this raw, going over to Andrew, talking about your swerve on it. You know, one of the things we were talking beforehand, you know, no need for a turret because your swerve is compensating for that. So tell me a little bit more about that, what went into it, and obviously, once again, seeing you on the field, seems like it's been working out quite well for you guys.
Yeah, so on these swerve modules, the one we're using are the Swerve Drive Specialties MK2 modules. We chose these because a lot of choice and movement, and also they negate the need for a turret, because due to targeting, you can move and spin at the same time. This gives us a lot of time off manufacturing a turret and many other things, and saves us power. And also, it's great for defense and offense. If we're getting pinned by a robot, we can easily spin around them so we can move in any direction freely, which is what helped us a lot getting those endgame shots off. And it was also able to help us stop a few climbers in the endgame, just the ability to move around them when they can't maneuver as much with the tank drive.
Well, 4206 Robotics, thank you so much for taking the time to speak to us here about your robot. Can't wait to see. Hopefully this robot gets a chance to compete in other competitions this year. We'll see, but if not, can't wait to see what this team produces in future years. Thanks for taking the time.
Thank you so much. It was nice being here.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with the company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.